We want to write the exponential form of the complex numbers in Cartesian or rectangular form, which is the form a plus or minus bi. To do this, we'll first write the exponential form in polar form, and then write the polar form in Cartesian form. So looking at our first complex number, we should recognize that r is equal to 3, and theta is equal to pi. So we would have 3 times cosine pi radians plus I sine pi radians. Well, cosine pi radians is equal to -1, and sine pi radians is equal to 0. Notice how this simplifies to the real number, -3. So if we were to plot this number on the complex plane, because it's real, it would be on the real axis, it would be this point right here. Notice how the radius is equal to 3, and the angle theta from the positive x-axis would be pi radians. Now let's take a look at our second example. Again, the first thing we should recognize is that r is equal to 5, and theta is equal to pi over 2. So we would have 5 times cosine pi over 2 radians plus I sine pi over 2 radians. So this will give us 5 times, well, cosine pi over 2 radians is equal to 0, and sine pi over 2 radians is equal to 1. So this is just 5 times I, or 5i, which is an imaginary number. So if we plot this number on the complex plane, because it's imaginary, it would be on the imaginary axis, up 5 units. Here it is. Again, notice how the radius is 5, and the angle theta from the positive x-axis would be pi over 2 radians. Now let's look at one more example. Again, r is equal to 7, and theta is equal to 4. So we'll have 7 times cosine 4 radians plus I sine 4 radians. We're not going to be able to find these trig function values on the unit circle or using reference triangles, so we'll have to get a decimal approximation using the calculator. We want to make sure that we are in radian mode, so I'll press the mode key. Notice we are in radian mode, so we'll go back to the home screen. So we want cosine 4 radians. This is approximately -0.6536. Let's go ahead and multiply this by 7 as well, because we are going to distribute. So A is going to be approximately -4.5755. Now we need the value of sine 4 radians, which is approximately -0.7568. Again, we're going to multiply this by 7 because we have to distribute. So the imaginary part of our complex number will be approximately -5.2976. So 7 times e raised to the power of 4i is approximately equal to -4.5755 minus 5.2976i. If you were to plot this complex number, the real part is approximately -4.6. The imaginary part is approximately -5.2, so maybe somewhere in here. The radius, or this distance here, would be 7. And the angle theta from the positive x-axis, from here to here, would be 4 radians. Okay, hope you found these 3 examples helpful.